Hey guys, we're going to go over your homework a little bit differently for page 6. So here are all the answers that you should have. After you've checked your answers, if you have something that's wrong, then you can skip forward to the part of the video where I will write out and go over that question, and that way you can just focus on things that you need help with. Alright, so we're going to do some of these from the first reaction. So if I look at the first question, then I'm going to look for the islands. I see something about moles and something about moles. So if I look at mole islands, that falls, scoot that down a little bit, moles and moles are here and here. So I can do that in one step. So this is just going to be one fence. So the number that I'm given is 5.0, but I'm going to think before I write. Thinking about the fact that I'm going from moles to moles, I don't want to write moles in my fences. I'm going to tell these two things apart using the chemicals instead. So I'm starting with moles of hydrogen. So if I look up in the reaction, here is hydrogen. That's what I'm going to put instead of moles. There's too many moles, it's not going to help me here. Okay, so moles up. I'm going to put moles down. The chemical that I want, I'm looking for moles of water, so I put H2O on top. Whenever you have chemicals together in a fence, you're going to use the coefficients. So if I look for hydrogen, the coefficient right here is a 2, and for water, it's also a 2. When you go ahead and put that in your calculator, 5 times 2 divided by 2, your calculator says 5. The reason that we wrote 5.0 here was for sig figs. We started with 2 sig figs, and so to make this 2 sig figs, we can add the 0.0, and then it's got the sig figs that we want. Don't forget to put your units on. You were looking for moles, so you have to add that moles there. If you want to be fancy and put H2O on there, that's okay too, but you have to put moles on for your unit. Get rid of this. Let's take a peek at the next question. Find your units. I see moles and moles in this question as well. So if I look for moles there, I see mole island here and mole island here. So that means this is another one-step fence, just like this. I'm going to start with what I was given for a number, 4.0, but again, because this is moles and moles, we are not going to write moles in our fences. That doesn't help us. We want to look at the chemicals that we were given. So this is moles of hydrogen, which means H2 there. That's going to go down. I'm looking for moles of oxygen, and so we don't write moles in here. We're going to tell these two things apart with the chemicals. Whenever you put chemicals into your fences, you're going to put a 1 next to the oxygen because that's the coefficient that's up there, and hydrogen has a 2 next to it, so that will go there. When you put this in your calculator, you times on the top, divide down, your calculator will say 2. Then you're going to check out your sig figs. The number we started with had 2. To make this have 2 sig figs, you can put a 0.0 on the end. Then don't forget your units. You were looking for moles, so you have to add moles as a unit. Do not just write 2.002s. That doesn't tell me anything. You have to put moles. If you want to then also add O2, that is totally okay. Let's take a peek at question number 3. First, find the fences that you're dealing with. I see molecules and I see molecules. So let's find those two islands. Remember, molecule is a kind of particle, so I'm going from one particle to the other. So that takes 1, 2, 3 steps. So this is going to be a big fence. Start with the number that you're given, which is here. So 2.0 times 10 to the 22. If you want to abbreviate molecules, you can do it with an MC. So, first fence, I'm going to go from molecules here up to moles. So that means I need molecules and moles in my fence. Since molecule is up, it will go down. I want to find moles. So that just took us from there, and now we're here on this mole. In my next fence, I'm going to go from mole over to mole. In this part, we are not going to write the word mole because everything here will be mole. Instead, we're going to use the chemicals that we were given. The first chemical that I started with, and when I say first, I mean what was attached to the number. So I had 2.0 times 10 to the 22 molecules of hydrogen. That's the starting chemical. The starting chemical always goes on the bottom, so I put H2 there. The new chemical that I want, I'm looking for how many molecules of water. So I want to switch to water. That just took us from mole 1 to this other mole island, so now we're here. In our last fence, we're going to go from mole down here to the other molecule or particle island. That means it's okay for us to write mole in our fence again. Since we want molecules, we'll put molecules on top, which means that mole can go down here. Now you just have to fill in a number. Wherever you've written mole, you know to put a 1. Molecules uses Avogadro's number, 6.02 times 10 to the 23rd. Where you've got these two chemicals in the middle, use the coefficients. So sneak back up to your reaction. H2O has a 2 in front of it, and H2 also has a 2 in front of it, so that will go there. Then you have to put this whole thing into your calculator. When you do that, remember to times and then divide. Then go back up to the top, times and then divide. Then go back up to the top, times and then divide. When you hit equal, your calculator will say something funny like 2E22. Remember that that E actually means times 10. And the reason that we wrote a 2.0 was because of the sig figs. We started with 2 sig figs at the beginning. So what I want to do is I want to put that 0.0 right here so that I have 2 sig figs at the end. I'm going to put molecules on as my unit because that's what I was looking for. If you want to put the water on, that's an option. You don't have to do that. You must include the molecules though. Let's try another one. Let's try the last one that goes with this reaction. So here, if I look at my fences, I see grams and I see grams. So we're going to look for those islands. Grams means the same thing as mass, so we're going from here way over to there. So that's going to be 1, 2, 3 steps. So this is going to be another big 3 fence. So I'm going to start with 5.0. In my first step, I'm going to go from mass to moles. So that means it's okay to put the grams and the moles in my fence. So I'm going to bring grams up, grams down, and first I'm going to go to mole island number 1. In my next fence, I'm going to go from mole to mole. That means I don't want to write mole in this section of my fence. Because it's all mole, that's not a helpful thing to include. The way you're going to tell the difference between these is by using the different chemicals. I started with grams of oxygen. The starting chemical always goes down on the bottom, so O2 goes there. I want to find grams of hydrogen, which goes up here. So that just took you from mole to mole. The last step we have to do is go from mole up to mass. That means it's okay to write moles and grams in our fence again. Since I'm looking for grams, that goes on the top. Moles can slide down to the bottom then, and then you just have to put the numbers in. You always put 1 with the mole. When you have grams, look at the next door neighbor and find the mass of that. So if I find the mass of oxygen, there's 2 of them. They weigh 16 apiece, so that means this mass will be 32. For this grams, I'm going to look at that neighbor right next door. Each hydrogen weighs 1 apiece, so 2 times 1, that mass is 2. Lastly, we have to put in our chemicals with our coefficients. So if I go back up to the reaction, H2 has a 2 in front of it, and O2 has a 1. So 2 there, 1 there. Then we're going to put this whole thing into our calculators. And mine says 0.625. And lastly, we're going to do our sig figs because they're never going away. I started over here with 2 sig figs. That means if I round this to the second sig fig, that 2 will round up to a 3, so I have 0.63. We were looking for grams, so you're going to put that on your unit there. If you'd like to add the H2, you can. Let's talk about the next reaction. If you needed some help here, let's find our islands. Number 5 mentions grams and moles. So let's see what we can find in our mole islands for that. So I have grams. The question is, do I go to this mole or to this mole? Remember, the way to tell that is by seeing if it is the same chemical or if you have a different chemical. So let's look at what we have. We have grams of KClO3 and moles of oxygen. Those are different chemicals. What that means is I cannot stay on the same side. I have to go over where it's different, so I'm going to go over here to this mole. That takes 2 steps. I'm going to start with my number, 45.0. In my first fence, I'm going to go from mass to moles. That means that it's okay to write mass and moles in my fence. So I'm going to have grams, and I'm going to bring it down, and I'm going to go to mole island first. That just took me from mass over here to moles. In my next fence, I'm going to go from moles to moles. That means for this section of the fence, I don't want to write moles because it's all moles. I want to write something more helpful, which will be the chemicals. So the chemical that I started with, and the starting chemical means the thing that has the number attached to it, is right here, 45.0 grams of KClO3. The chemical that you start with will go on the bottom. The chemical that you want, which in this case is oxygen, goes on top. Then you just have to fill in the numbers. You know to put 1 with the mole. For grams, you have to look at the next door neighbor. So we need to find the mass of this chemical. So we're going to do that. K weighs 39, Cl weighs 35, and then there are 3 oxygens times 16 apiece. Add all of that up, and the molar mass that you should get is 122 grams. Lastly, I need to put in my coefficients to go with my chemicals over here. Oxygen will get a 3 because that's the coefficient it has, and KClO3 will get a 2. Then you just have to put all that into your calculator. Remember, when you do this, times, divide, my calculator says 0.553278 blah blah blah. Sig figs. We started with 3. We're going to end with 3, which is the third sig fig here. The reason we left it a 3 was because of the 2 afterwards, and then we put our unit on. Do not write 0.55302s. That doesn't tell me anything. I need you to tell me that we were looking for moles first. Then you can always add O2 if you would like to. Alright, let's take a peek at our next question. Find what you're looking for. I see something about molecules and I see something about mass. Okay, so molecules lives down here on Particle Island. The problem is, do we go to this mass island or to this mass island? You have a choice, right? But only one of them is actually right. What I want you to think about is, are you dealing with the same chemical or are you dealing with different chemicals? So let's take a peek at what we have. We started with molecules of oxygen, and it mentions the mass of potassium chloride. Those are 2 different chemicals, so I can't stay on the same side. What that means is I've got to go way over here to this mass island. That takes 1, 2, 3 fences. So let's start. Take the number that you were given, 2.5 times 10 to the 23rd. Molecules, you can abbreviate MC. First, I'm going to go from molecules to moles. So molecules down, I'm going to moles. That just took me from there, and now I'm here. In your next fence, you're going to go from moles to moles. That means this section of the fence will not put moles in it. You have to write the chemicals to tell things apart instead. So the chemical that I started with means what was attached to the number, so it's 2.5 times 10 to the 23rd molecules of oxygen. Make sure you look back at the reaction for what oxygen is. Oxygen up here is written as O2, so don't just write O, use the reaction to help you. It is O2. Oops. The chemical that I want is potassium chloride. You don't have to figure out what that is. Find what's up in the reaction with potassium and chloride in it. That's this thing right here, KCl. That's the new chemical that we want to switch to. Okay? Oops, put that back. In my next fence, we just did that mole. I'm going to go from this mole up to mass, so the last bit of our fence. Because they're not both mole, it's okay to write moles and grams again. So the thing I want is grams, which means moles can go on the bottom. Now we just have to put all of our numbers in. We always write one with the mole. Molecules gets Avogadro's number. When I have two chemicals together, that means, that I need to use the coefficients. KCl has a 2 in front of it. O has a 3. And lastly, I need to do the grams. So the grams will always be of the neighbor. So find the mass of KCl. So K is 39, Cl is 35. So the mass that I was looking for there should have been 74. Now you have to put all of this into your calculator. Times, divide, go up. Times, divide, go up. Times, divide. My calculator says 20.4872. Check out your sig figs. I'm looking for 2. That second sig fig is here. What that means is I have to decide, am I going to leave that as a 20 or should I round it up to a 21? Because there's a 4 after it, you can leave it as a 20. But because of that 0, it's tricky. If you leave it 20 like this, that only has 1 sig fig, and that's not enough. The way that you're going to make it 2 sig figs is by adding the decimal point. Then it's a Pacific number, so it counts. That means you have to have the decimal or you're going to get it wrong. Okay? Lastly, you're going to put your unit on. You were looking for mass, so I'm going to put grams down there. If you'd like to add the chemical, we were looking for KCl. Alright, let's check out the next one. Here I see grams and I see moles in my fence. So let's find those two islands. They give me a number in moles, so that means I'm here. The question is, are we going to this mass or are we going to this mass? The way that we'll figure that out is if it's the same chemical, we can stay on that side. If it's a different chemical, though, we'll have to cross over to the other one. So what's going to happen is we're going to look in the question. I see grams of potassium chloride and moles of potassium chloride. Those two are the same thing. That means I don't need anything on this side of Mole Island at all. What we can do is have a nice easy little fence. We're going to go to this mass. That only takes 1 step. So I'm going to start with 2.33 moles. It's going to go down. I want to end at grams. You know to write 1 with the mole. For grams, you need to find the molar mass. There was only one chemical here, so it is potassium chloride. But you have to know what is potassium chloride. So go back up to the reaction. Here's potassium chloride right there, potassium and chlorine. So let's find the mass of that. K is 39. Cl is 35. When you add that up, the molar mass you get is 74. Then you're just going to put that into your calculator. And my calculator says 172.42. Check out your sig figs. We started with 3 here. To end with 3, we're going to stop at this 2. I'm going to leave it 172, though. That 4 afterwards does not make it round up. Lastly, put your unit on. We were looking for grams, so that goes here. And if you'd like to add the chemical of KCl that you were looking for, that's okay too, but you don't have to do that if you don't want to. Alright, let's look at the last one that goes with this reaction. Find your units, find your islands. I see formula units and I see moles. Okay, so the number that they give me is moles, that's here. Then it says something about formula units, which is a kind of particle. So I don't know if that's here or maybe that's over here. The way that we're going to decide is if it's the same chemical, we'll stay on one side. If it's a different chemical, we'll cross over though. So I have KClO3 and potassium chloride. If you're not sure, go back to the reaction. Here's KClO3 and here's potassium chloride. Those are 2 different chemicals. That means that we have to cross over to the other side of Mole Islands. That means we've got to go over to this particles. Okay, that's where formula units lives. That takes 2 steps. So I'm going to start with 4.10. Think about the first thing you're going to do. You're going to go from moles to moles. That means there's no point in writing any moles in the beginning of my fence. That's not going to help you with anything. You can tell things apart by looking at the chemicals that go with them. This has 4.10 moles of KClO3. That's the chemical that I care about. So it's going to go up and then down. I want to have formula units of potassium chloride. If you remember from the reaction, here's potassium chloride. That's the other chemical that we're going to use here. In your next fence, you're going to go from moles down to these particles. So then it's okay to write moles again, and I want to end up with formula units. Now you just have to go ahead and put all your numbers in. When you've got the chemicals in there, you use the coefficients. So go back to your reaction. They both have 2's in front of them. You're going to put a 1 with the mole, and formula units uses Avogadro's number. When you put this in your calculator, remember to use the E. And mine says 2.4682E24. The third sig fig, because this has 3 sig figs, is right here at the 6. We're going to round that up to a 7 though, because of the 8 afterwards, and E24 means in people language times 10 to the 24. There we go. Remember to put a unit on. I was looking for formula units, which you can abbreviate FUN. If you'd like to add the chemical, that was of KCl. Okay, let's take a look at this last reaction, see if you need any help with this. If I look at the first one, find the islands that you're dealing with. I see grams and I see grams. So we find those islands. We've got grams and grams. That's mass. That takes 1, 2, 3 fences. So start with the number. I have 5.0. In my first fence, I'm going to go from grams to moles. So it's okay that we write grams and moles in our fence. So gram up, gram down. Next, I'm going to go to mole. In the next fence, we're going to go from moles to moles. That means in the next step, I don't want to write moles in my fences. When they're both moles, I want to use the coefficients and the chemicals. So the chemical that we started with is the one that was attached to the number. That's right here, 5.0 grams of silver nitrate. You don't have to figure out what that is. Look back at the reaction. This has silver and nitrate in it. So that's the formula for that chemical. The chemical that I'm looking for is grams of silver chloride. Again, find that up in your reaction. Here is silver and chlorine together. Then you're going to do your next fence, and you're going to go from this mole up to mass. That means it's okay to write moles and grams again. I want grams, which means moles can go down, and then you just have to put all your numbers in. We write 1 with all the moles. When we've got these 2 different chemicals, use your coefficients. They both have 2's in front of them if you look at the reaction. For the grams, you're going to look at the chemicals next door. So over here, I want to find the mass of AgNO3. In order to do that, Ag weighs 108, N weighs 14, and if I look at oxygen, there's 3 of them, and they weigh 16 apiece. If you add all of that up, the mass you should get is 170. So then I have to do the same thing on the other side over here. I need grams of this AgCl. Again, Ag is 108, Cl is 35. When you add that up, it equals 143. Then you just have to put that whole thing into your calculator. Remember to times, divide, times, divide, times, divide. So my calculator says 4.20588 something. We started with 2 sig figs, so we would also like to end with 2. That second sig fig is right here at the 2. I'm going to leave it a 2 because there's a 0 after it. So I'm going to keep the 4.2 here. Grams is the unit you were looking for. If you don't want to put the chemical, that's okay, but you do at least have to put the grams. Alright, let's look at the next one. Let's find the fences. I see grams and I see moles. Okay? So I start with 5.28 grams. That's here. The problem is, am I going to go to this mole or this mole? The way you're going to figure that out is if it's the same chemical or if it's a different chemical. So let's look at the question. We have grams of silver nitrate and moles of silver nitrate. Those are the same thing. That means I don't need this side at all. So the mole island that I will be looking for will be right here. So that's a nice one-step fence. So 5.28 grams. Grams will go down. I want to go to mole island. 1 will go with the moles, and grams means we need to find the molar mass. If you don't know what silver nitrate is, go find it up in the formula, the reaction. Silver nitrate is this chemical right here, so find the mass of that. Ag is 108, N is 14, and O is 3 times 16. When you add all of that up, add the whole thing together, the mass you should get is 170. Put that into your calculator. You get 0.0310588 blah blah blah. So then we have to round. When we're looking for sig figs here, we look here, we started with 3. These zeros do not count as significant, so that's not a sig fig, that's not a sig fig. The third sig fig is right here at this 0, but it's going to round up because of the 5. That means my answer becomes this, 0.0311. Grams was the unit that we were looking for, and if you want to add the chemical, you have that option. Alright, a couple more here. Let's look at the next one and find some islands. I see moles and I see grams, so let's make a decision there. I've got grams and I have to decide if it's this mole or this mole. So I'm going to divide my mole islands in half. If I have the same chemical, I'll stay on the same side. If it's a different chemical, I'll stay on the other side, or I'll go to the other side. So if I take a peek in the reaction, I have moles of barium chloride and grams of silver chloride. Those are different. That means that I have to scoot over to the other side of mole islands, which means I have to go to this mole because it's a different chemical. That takes 1, 2 steps. So I'm going to start with 0.956. In my first fence, I'm going to go from grams to moles. So I start with grams, bring it down, and go to mole island. That means I just went from mass, and now I'm on this first mole. In the next fence, I'm going to go from this mole to the other mole. That means I don't want to write moles over here. It's all moles, and that's not going to help me. The way that you're going to tell these apart is by using the different chemicals. So the chemical that we started with is the one that was stuck on the number. That is silver chloride. Go back to the reaction and find silver chloride. So if I look for silver chloride, that's this thing. So there's one of the chemicals, and that was my starting chemical. Whatever your starting chemical is, you go down to the bottom. The chemical that I want is barium chloride. Again, find it in the reaction. You don't have to guess. Barium chloride is right here. That's what will go next. Then what you're going to do is use your numbers. When I've got these two different chemicals together, use the coefficients. So BaCl2 has a coefficient of 1, AgCl has a 2. Moles always gets a 1 next to it. For grams, I need to find the mass and look at the neighbor. Find me the mass of AgCl. Ag weighs 108, Cl weighs 35. When you add those two numbers together, the mass you get is 143. Put all that into your calculator, and it will say 0.003342657. Then you're going to go through and check out your sig figs. I started with 3. That 0 does not count as significant. If I look for the third sig fig over here, these first initial zeros don't count as significant either. So that doesn't count, that doesn't count, that doesn't count. The third sig fig over is really at that 4. I left it as a 4 because of the 2 afterwards. Don't forget to put your units back on. You may not write 0.00334 BACL2. That doesn't tell me anything. You must include that mole in the unit. Okay, let's look at the next one and let's find out some islands. I see moles and I see formula units. So let's figure out where we're going. We start with formula units down here on particles, and I have to figure out, am I going to go to this mole or to this mole? If it's the same chemical, then you're going to stay on the same side. If it's a different chemical, you go over to the other side. I see moles of barium nitrate and formula units of silver nitrate. Those are different chemicals. What that means is I cannot stay on the same side. I have to go over to where it's different, which is here. That takes 2 steps. So we're going to start with that 4.36 times 10 to the 22 formula units. First I'm going to go from formula units up to moles. So I'm going to bring that down and go to mole island next. In the next fence I'm going to go from moles to moles. That means that can't have moles in it. You need to use the 2 different chemicals. The chemical that I started with, the one that was attached to the number, is silver nitrate. If I go back to my reaction and I look for silver nitrate, you don't have to guess at the formula. It's there for you right there. It's AgNO3. The chemical that I want to switch it to is barium nitrate. Again, you don't have to guess. Go up and find barium nitrate. That's this one. It has barium and nitrate in it. Now you just have to put your numbers in. So when I've got 2 different chemicals, use the coefficients. This has a 1 in front of it. This has a 2. Moles always gets a 1 with it. Formula units uses Avogadro's number. And then you just have to put everything into your calculator. When I do that, mine says 0.0362126. Check out your sig figs. You started with 3. You need to end with 3. These zeros don't count as significant. The third sig fig here is at that 2. I left it a 2 because of the 1 directly afterwards. Don't forget to put your units back on. You were solving for moles, so put that into your unit and your answer. If you'd like to write the chemical there, that is your option, but you do not have to do that. Alright, let's take a look at this last one if you need some help. So first let's find our islands. I see grams and I see grams. Okay, we've got mass here, mass here. That's a 1, 2, 3-step fence. I have 6.72 grams. First I'm going to go grams down, and I want to go to mole island. That's the next thing I put in my fence. Okay, so I already did that. Next I'm going to go from moles to moles. That means right here I'm not going to put moles into my fence. I'm going to use my chemicals instead so I can tell things apart. The starting chemical is what was attached to the number. That was grams of barium chloride. Don't guess. Look back at the formula and find barium chloride. You don't have to figure it out. Just look for it. Barium chloride is this thing. So let's write that formula. That was the starting chemical. Whenever you do this, the starting chemical goes down on the bottom. I'm looking for grams of silver chloride. If I look for that in the reaction, that's here. So AgCl is the new chemical that I want. Okay, so I'm done with that. The last step, I'm going to go from moles up to grams. I'm looking for grams, so moles will go down here. Then you just have to put all of your numbers in, one with the mole. For grams, look at the next door neighbor. I want the grams of BaCl2. Ba is 137. There are 2 chlorines that weigh 35 apiece. When I add all of that up, that gives me a mass of 207. For grams of this, I want to look at the next door neighbor, AgCl. Ag is 108, Cl is 35. When you add that, your mass is 143. When you've got these two chemicals together, I want you to use the coefficients. Ag has a 2 in front, BaCl2 has a 1. Now you're ready to put this whole thing in your calculator. Times divide, times divide, times divide. My calculator says 9.284637. The sig figs, I started with 3 and I ended with 3, right there. The reason that we left that 8 alone was because of the 4 after it. Lastly, I was solving for grams, so you need to put grams on your unit. Alright, that's it. Come see me if you have any more questions.